SOA, Microservices, and Service Boundaries on this episode of the Loosely Coupled Show with James Hickey and Derek Comartin. This episode was recorded May 8th, 2020 with our guest, Adam Ralph. If you enjoy the Loosely Coupled Show, make sure to subscribe to our channel on YouTube. If you enjoy this episode, make sure to give it a thumbs up and leave your comments. We'd love to hear from you.
All right. Thank you for coming to the Loosely Coupled Show, whoever is watching this. Today we have Adam Ralph, and if you're watching this, you might know who Adam is. I'll just do a brief introduction. Maybe, Adam, you have something else to say? I don't know. So Adam works for Particular Software, the makers of Service Bus, and Service Bus gives lots of cool messaging, event-driven abilities for .NET applications. Awesome product. And Adam does a lot of conference speaking. I've watched quite a few of your talks, Adam. And that's probably one of the big reasons we're familiar with you is a lot of the talks you've done on SOA and service boundaries and messaging and those kinds of things. So yeah, thanks for having a chat and meeting with us today.
Yeah, thanks for having me on the show. Unfortunately, I haven't done so much conference speaking this year for obvious reasons, but that's something I hope to get back into.
Yeah.
Yeah.
Are you doing any online conferences or anything like that?
There's one coming up shortly. It's a virtual DDD event, which I'm still waiting to hear back from. So I might be taking part in that. And I think I heard that Orodev might just be going online. I think I just heard that off the press, so I might be there, but we'll wait and see.
Okay. Yeah, I think I'll be doing something for the virtual DDD next week. So that's good for me because I've been wanting to get involved in speaking, but I can't travel right now, so it's kind of this, well, what do you do? So it's nice. It's nice benefit for people like me.
Well, we're all in the same boat right now.
Yeah, that's it. Yeah, so level playing field now. Yeah, so I have just a list. I drew up just a brief list, but I think it seems like a lot of your experiences with, obviously, with working for Particular, like service-oriented architecture, and probably for our viewers, I would think, just because of the hype around microservices, I don't know why, but it just seems like microservices is just crazy. People are going crazy about it. Yeah, and to me, it seems weird. I don't know if it's just because it's a lot of, I don't want to say newer developers, or maybe developers who aren't familiar with kind of history, a lot of the historical stuff, developments in software development. But when I read about microservices and when I see what people are doing and how they're doing it, it just, I cringe. I cringe because I'm familiar with how SOA works, and I know SOA gets a bad rap. A lot of SOA has been done poorly, I would say. And I think that goes back to, like, with .NET in particular, you think of Windows Communication Foundation, like those kind of, like, just the way people were doing web services with that technology, and there was kind of a bad way of doing it, I think. But that's not really SOA, so maybe you want to either agree or disagree with me and maybe talk about, like, SOA and how that differs maybe from microservices, and are there advantages?
Well, I mean,
one or the other?
Well, as you said, it's one of the things that I talk about fairly often, SOA and service-oriented architecture and trying to find service boundaries and that kind of thing. And the topic of microservices comes up quite often. And sometimes I even get the feeling that I'm kind of the guy standing up talking about the old boring SOA stuff, but everyone wants to do the new shiny microservice stuff, right? Because that's kind of like the new hotness. But I think that microservices is like many things in our industry. It's something that was a reaction to a set of problems. So as you said, SOA started out saying one thing, but it got kind of conflated with things like web services and WCF services and things like that. And people started to think of service-oriented architecture being that, where you have kind of like, I don't know, maybe HTTP endpoints talking to each other. And I think microservices was a reaction to that, to say, well, hang on a minute, let's stop building these huge web services. Let's kind of pare things down to smaller things. But I think like a lot of things in our industry, we kind of swung that pendulum too far. And in some cases, I've seen things that were monoliths with just a bunch of classes being broken down into web services and then broken down even further and broken down even further until you've got the same monolith just talking to itself over HTTP.
Yeah.
And I've seen, it's a coincidence, I've seen a number of blog posts just in the last couple of weeks saying how we've gone back to a monolith. You know, we tried microservices that didn't work out, and we've gone back to a monolith. So it's not that the idea of microservices is incompatible with SOA. I just think the pendulum has been swung a bit too far in many circumstances. People have got themselves into a real mess.
So I think, would you say it's more because people are approaching it as a technological solution as opposed to an organizational solution along those lines?
I think that's one of the main problems, yes.
Yeah.
Because service-oriented architecture, funnily enough, isn't really about technology. It's more about recognizing the business capabilities of your domain. That's really what service-oriented architecture is about. Now, there are various technical constraints that fall out of that, but it's primarily that. It's primarily a logical thing for finding the logical boundaries in your domain. And the problem with microservices is it's become too conflated with a running component is your microservice and that is your boundary. So it's become too focused on the technical boundaries. And it has become, to a large part and degree, a technical solution which kind of it kind of ignores those logical business boundaries to some extent. And I think that's one of the things that really concerns me.
Yeah, it's interesting because on Twitter a couple of weeks ago, shout out to Nick Toon, posted something along the lines of, if we called them business components, would that have changed anything? And my answer was no, because generally everybody's so fixated on technical concerns that even if the word business was in the name, it still would have ended up being like a technical organization rather than a business concern, like you just said, business capabilities. And I guess that would be my question. Why do you think the focus is such on always on this technical? Because it runs deep, this whole organizing stuff by technical concern, by service, by even project structure internally in your source code. Like I always make the comment of how I always think organizing the scaffolding in like a web app of MVC, just that technical nature of everything being organized technically all the time. It really runs deep versus concerning yourself about like you said, business capabilities.
I think part of it is our psychology as engineers, I think. So as engineers, we like to, I think in some ways we're lazy, right? Now, laziness doesn't mean bad, right? There are good parts of laziness and it's good to be lazy in some aspects. But I think what we do is we'll find a solution, like break down your thing into these little services, right? Because that makes it easier to deploy each of them and to worry about each of them in isolation, all the rest of it. And we go, right, that's a good solution. I'm going to do that everywhere, right? And that becomes our solution. Now, the thing is that the most difficult things that I've found when working with systems is understanding the domain, right? It's understanding the business, and it's looking for those separations of concern in the business. Now the thing is that each time you try and tackle a bit of that, you've got to do all that question asking again. So you go into one part of the domain, you learn it, you find out what it's all about, that's done. You go to another part, you've got to start that process all over again, and that's a lot of work, it's a lot of investment. Now, I think when we've got something that is compelling as a technical solution, say, well, you can kind of shortcut that. All you have to do is break things down really small. I think as engineers, we have a tendency to kind of latch onto solutions like that as a easier path, a path with less friction, maybe. And I can see why. I mean, faced with complex systems and lots of demands, it can seem like a much easier way out. But at the end of the day, it's very difficult to avoid asking those really hard business questions about your domain. There's no getting away from trying to learn about that domain and answer those questions.
Yeah, I think this one of the hard things with that is because when you actually do it, part of that is, like you said, discovering the boundaries between context A, context B, and or if you want to say business capabilities, even within, let's say, a DDD domain or bounded context. I think the struggle with most developers is that process is so inverted. Like what you end up with is so inverted to what we're used to. Like the thinking is so switched around. I know you talk about this in one of the talks you've done with particular. I think it's called Discovering Service Boundaries or something like that. Mm-hmm. And I think at the beginning of it, you basically said, like, I'm going to flip this upside down. Like what you think we're going to end up with is totally backwards. And I remember when I first started learning like SOA concepts, even like domain-driven design and SOA, I think there's definitely a big overlap between them. But yeah, definitely when you're examining, okay, this piece of data actually should belong over here, and this one belongs over here, and this one belongs over here because these ones actually affect each other, and they don't affect this one. That model you end up with is like nothing. It's not even close to what you would probably imagine, right? Mm-hmm. And I know you had mentioned in that talk, you had mentioned a project that you had worked on where you guys ended up just naming the services like dumb names. I think like Japanese monster names or whatever, mm-hmm. or name this service blue, service red, because the names actually don't. If you try to name it, it kind of puts a barrier between actually like doing the hard work of figuring out how you're going to split this apart. So I think that is very difficult. I know, like you're saying, is we like to start breaking it down, breaking a hard, complex problem down into chunks, but then we break it up this way, and it actually should have been broken up this way, like kind of maybe horizontally instead of vertically. Yeah, and that is tough. So maybe, do you have any pointers, like for people, maybe developers who are just don't understand like how different it might be?
Sure. Well, actually, another another good example of that is object-oriented programming, right? So again, that is a kind of a technical thing we've become familiar with, and you might speak to your business expert, your domain expert, whatever you want to call them, and they might tell you that we've got customers and products. Now, it's very tempting and compelling to go to our whiteboard and draw a box for customers and a box for products. And, you can kind of take that mental leap to say, well, they can actually end up being our classes and our entities and our objects and our object-oriented design. Yeah. And it's
we might even make that. We might even say like that is going to be a microservice too, right? Like
absolutely.
Absolutely. We're just talking about this one area. Let's just
carve it off and exactly. And I can see why, from a technical point of view, that's a compelling thing. But it's really interesting when you start to look inside those boxes, because, and this is one of the examples I give in one of my talks, but they might tell you something like a customer has a name and a status. They're like a gold customer or a silver customer or just a regular customer. And they might say, well, a product's got a kind of name and a price, right? So you kind of write those things in your boxes. But if you start to look inside the boxes and look at the relationships between the data, you can ask your business a dumb question like, if the customer's name is more than 10 characters, does it affect their status? Right, and they'll look at you in a weird way and say, that's the dumbest question I've ever heard. But it's good because they're saying that there's no relationship between the name and the status. So then you've got to ask yourself, well, why are they in the same box? What if you put them in separate boxes? Mm-hmm. Draw two new boxes, and then you can look at the product and you can say, well, what's the product price? What's that all about? And they say, well, yeah, that's what we charge for the product, but it depends what the customer status is. So there's a relationship between status and price, so you put them in the same box. So all of a sudden you've got very different boxes to the things you originally drew.
Yeah.
And that's what service-oriented architecture is about. It's about finding the relationships between data. It's about behaviors of the system and not the kind of nouns of the system. And that's one example where you can end up with a very different model, depending on which approach you take.
Yeah, it's I don't want to say it's funny. It's maybe ironic, because one of the classic code smells is I forget what the name is. Something about like being intimate with other classes. I think the name is something intimacy, whatever.
Inappropriate intimacy, I think.
And in this case, like you're saying, if you had the customer and your product, what you would end up seeing in object-oriented code is that your customer, or your product, or your customer, whichever way it works out, is always reaching into the other to check, oh, what's his status? What's his status? What's his status? What's his status?
Right.
So if you think of that, okay, let's put a network between those two now. Like we're doing microservices, let's put a network between them. That essentially translates into a lot of REST calls or HTTP. Whereas if we model it in just objects, like you had mentioned, now your price and your status are in one class, for example, and you don't have all that chattiness going on. It's funny how we recognize that in our objects. Well, not all the time, but we recognize that's an issue, right? That's a classic code smell. But then when we do microservices, I understand why we don't see it, but it's essentially the exact same thing, right? It's just you put a network in between your objects instead of doing it in memory. And
when you've got that separation, then that kind of thing about taking that to being an independent service or independent running thing works out a lot better for those reasons, because you won't have that network call, because all you need to do to work out the price is the stuff you've already got, right? Yeah. You've got the status, you've got the base price, you just work out the price. And you don't need to know about the customer's name when you do that. And you don't need to know about the product name when you do that.
Yeah. Yeah, I think to me, that seems like the biggest hurdle, is wrapping your head around just this paradigm shift of I have to approach this in a totally different way. How do you have experience trying to coach teams, or have you been in an instance where, as a team, you've tried to like change the way you've been building systems closer to that way?
Yeah, sure. And now here comes the difficult part.
As the rubber meets the road.
Yeah, and that's one of the questions I get asked the most often, is how do you move towards something like this? If you've got a massive monolith, how do you even start? One of the biggest ingredients is time, right? That's the biggest ingredient, and I don't think anyone should ever be too ambitious about being able to do this too quickly.
Yeah.
Depending on the complexity and the size of the system, this is not a weeks, not even a month. It's usually a year's kind of time span to move something across to something like this. And you've got to start carving little bits out, maybe adopting a kind of strangler pattern, where you just kind of like carve bits out until you strangle the core horribleness out of existence. But the problem with that, and that's sometimes difficult to accept, is while you're doing that, things will probably look a lot worse. Because you've kind of got this, one analogy you can make is you try to take a bus and make it fly. And for a while, you've got this bus going down the road with one wing on the side, picking up people from the bus stop. But, eventually, one day that bus is going to take off. So it's sometimes difficult to convince people that pain of the weirdness is worth it for what you're going to get at the end. But it's more than likely going to take that shape.
I'm curious if a benefit, though, if you're taking an existing system, and this has some caveats here, or it has some assumptions I'm making, that is, if you're working with developers that have been working on the system and understand the domain fairly well, is it more recognizable then, the way it probably should look once they understand maybe fundamentally what the differences are? In terms of really understanding what those boundaries are, because they understand the domain a little bit better. It's a little clearer maybe about, this actually, now we get this. This should probably be here. This should have probably been here once we start doing this. As opposed to, in my experience, especially if you're jumping into something that's completely new, there's I always equate this to, I'm going into a dark room with a flashlight, and I have no idea what the shape of the room looks like, right? Like, my mental model of this whole thing is so limited, and it takes so much time to really get the gist of what everything looks like. So I'm curious of what situation is better to be in, like being in one that you're so limited in knowledge, or one that you have this existing system that you are trying to turn from a bus to a plane. There's probably no good way to deal with it, but I don't know where I'd rather start, like probably with the existing knowledge to some degree.
It's a very good question. So I think what we've got to appreciate is there are a number of different scenarios here. So one might be where you're completely new to the system, like you say, and everyone's new to it because you're a startup, right? You're a startup. Now, in a startup situation, you don't yet know what your business even is, right? Typically. So, it takes most startups a number of years before they even realize what business they're in. Like Facebook suddenly woke up one day and realized they're a media company. So when you're in that situation, you've got to be careful about trying to invest too much time into doing this kind of thing, because once you find out what your business is, you're going to have to rip everything up and throw it away anyway. Right? So you're almost better just scattering your toys out on the floor and making a mess and seeing what fits, and then maybe when you find out what your business is, then start looking for stable business boundaries and business abstractions. Now, in more of an existing business, I think, again, there are two sides to that, because sometimes if you've been working with a system for too long, you're kind of too close to the problem, and it's really difficult to kind of step back and say, what actually is this thing? Because you're just too involved. So yes, while the insight you've got into the domain is valuable, it can come with that trade-off of being too close to the system. So it's almost like sometimes you might need someone new to come along and just ask dumb questions, right? And those dumb questions can give you real insights.
But I like to ask some dumb questions.
Is
that your job?
Absolutely, yeah. I'm very good at asking dumb questions.
That'll be your Twitter headline, whatever your tagline.
Right, but I also like the analogy you made about stumbling around in a room with a flashlight, because when you're trying to find service boundaries, that's exactly how it feels. Especially at the beginning, you kind of bumping around in this kind of dark room, smashing into things, and it's a really it can be an unnerving experience. And in the startup, you don't even have a flashlight, right?
Pretty well.
No one knows where they are.
Yeah.
But what I say to someone, if they're trying to do this and they feel like that, don't worry, that's normal, right? Even if I go in and trying to find out about domains now, that's exactly how I feel, right? So it's normal, but there's insights come. Eventually someone finds a lamp in the corner and switches it on, and you start to get an idea of things.
Yeah, that's exactly it. The one thing I usually feel like, whether this is right or wrong, it's always how it is for me, is it feels like getting service boundaries right is so important, yet it seems like when you're in that mode, it's almost impossible to do anyways, like to get them right, whatever right is. It's a struggle basically to feel like you're getting them right. And you just know it's not going to happen.
I mean, you're right. There's no right. There's no perfection, right? It's all about trading things against each other and then getting to the point where you are least likely to have to kind of rip things up completely to add something new or make something better or make a change. But I think the biggest problem that I see is I see the inability to separate the physical from the logical. So I see all too often developers saying, well, here's my service, right? I'm deploying this service, and that's my boundary. But a service-oriented architecture is not a physical thing. It's a logical thing. So a service is kind of a logical business capability. And within that, you might have 3 or 4 different components you deploy. And here's the other thing. You might develop components in different services and deploy them in one thing, right? So a front end is a good example of that. A front end is very much a collaboration between services. So there are various methods now which are starting to appear of saying, well, I'm going to build, let's say, a website front end. And that service and that service and that service, those logical business capabilities are going to ship this component, which I'm going to plug into my front end. And they're going to render part of the screen, right? So it's not that a service is a component. A service can have many components in one app, or it can have many apps within itself, many components within itself. It's a kind of many-to-many relationship. I don't know if that makes sense without looking at a picture, but...
Yeah, I think too, the example I gave, and I don't know if this fits exactly what you're saying, so you can see if I'm with this or not, is the idea of in .NET Core now, the ability to have a hosted service. So a hosted service, right, it fits alongside, I think they came out in .NET Core 3, the idea of a hosted service, but you can have basically the entry of your program, CS, and your main, right? And you can have multiple, what you would have thought of before as, originally just started as the web host builder, but then it was just a general host builder, where you could kind of combine all these separate services, but physically host them in one running executable, like one actual process, right? Like these things can be completely separate, but just end up physically being hosted together.
But see, this is one of the problems, is that the word service is so overloaded. Right?
Everything's a service. Everything is a service.
Yeah.
Yeah, because you say hosted service, and although it's the same word, it's a very, very different concept to what a service is in service-oriented architecture.
Yeah.
Because yes, so you could take. I like to call them something like autonomous components or something like that. Like, I try and avoid the word service for the physical things that I deploy. Like I don't know, a DLL or whatever it is. I tend to stay away from service, or even a running Windows service. Right? It's again just another use of the word service. But yes, you could have several components developed by several service-oriented architecture services, which ship something, which ship several components which are hosted together in one running executable, let's call it.
Sure.
Yeah. So there's lots of various technical hosting solutions now, which are pretty interesting.
Yeah, it's that this whole concept of like including the UI as part of a service is actually how one of the projects I have works, exactly how you had mentioned. So it's like all the back end, all the logic, and even the UI just ships as like a NuGet package and the developers has to like, it's just a couple lines, a few lines of code to configure it, and then you magically have like this additional application that's just kind of sidecarred onto your existing one. Now it's interesting, like even you think of SOA, take that approach for companies who are building their own products for other, that, you know, you would use as part of another product, I guess, you know, like a third party kind of thing. I guess this goes more along the lines of like a plug-in architecture kind of thing, but what's interesting about SOA is you're essentially doing that within your organization. But yeah, the whole idea of the UI, like the company I'm working for right now, I've been doing a lot of this. Like you said, it takes years, right? So I started doing this stuff like three years ago. And yeah, it takes a long time for the training and figuring things out, and how do you move forward? Even like these questions of, we have this existing web of systems, legacy systems. How do we start moving forward with new functionality and at the same time improve what we have? And a lot of the SOA ideas just totally changed like how the company builds stuff today. And one of the big things is exactly like you mentioned, the whole idea of like micro front ends, or whatever you want to call them, where now we build features on their own, their sidecards, so to speak, and they have their own UI components. And then if, for example, we want to add new functionality to, like one of our systems is like a old web forms application done in Visual Basic. So we can code in C# and we can use modern front-end technologies like Vue.js or React or whatever. I don't know if Angular you'd be able to do this with Angular, but definitely with React and Vue.js. And you literally just go on the legacy code page and drop in like one script or whatever. And then now you have this new component on your legacy app, but it's not garbled into the mess that exists, right? So that's another big benefit that I've found with these approaches, is not even taking old stuff and trying to rejuvenate it, but even moving forward, there's a lot of those, using those techniques can help you kind of backport newer features into these really old systems. So I mean, in terms of like time to market for a company and delivering value to customers, like those kinds of things, and the ability to use newer technologies, but then integrate them into legacy systems, there's a huge benefit there.
I think so, yeah. And that's part of that whole embracing the weird looking phase. Right?
Yeah.
It's like that's a whole bus with one wing on it. It's like sometimes I say, well, you know, just have an iframe, right? If it's in the website, just have an iframe with the thing from the old website in it, or the other way around. If you've got like an old, I know even a VB6 app, just drop a web browser control in the form and ship the new part in that. You know, it's really weird and really odd and really clunky, but it'll allow you to move forward. So you shouldn't be afraid of doing things like that. Obviously, you know, there's more sophisticated methods like the one you mentioned, but no one should be afraid of doing that kind of thing.
Yeah.
If it allows that transition.
Yeah, and I think that comes back to the whole discussion we had about focusing on the technical implementation versus, well, in this case, it's what are the business needs, but kind of that separation between what does a business look like and what do they need versus it's all about technology. And yeah, it's like, yeah, sometimes you maybe have to do something that feels a little dirty or a little, I don't want to say hacky, but a little different maybe. But it helps the business move forward and it helps them deliver value. But definitely with like these approaches, I don't think that, like you said, if you have to drop an iframe on a page and include something in there, like that might feel hacky. But then when you consider all the benefits you get to now write the like domain logic and all that stuff in a different way, you might get benefits like, oh, now we can actually test our code. We can add automated tests to our new stuff. It's easy to onboard people onto this stuff. Or
Well,
like you said, you can deploy them as their own autonomous components if you want to do that too. So yeah.
I think there are hacks and there are hacks, right? Because there are hacks where, you know, you've got this kind of big monolith and you're just hacking more. You're hacking more coupling into it. You're just saying, okay, well, you know, we could kind of change things around to make them look a bit nicer, or we could just say, well, let's just get that data from there to there. Let's just hack it, right? Now, you could argue that that's just making things worse, whereas the hacks that we just talked about, where you're saying, well, just put a completely new thing into your other thing in this clunky way, it's a hack, but it's a hack to allow you to move towards separation. So, you know, a hack is not just a hack. It's it falls into one of those kind of types of hack. I guess, you know, I guess I'm saying there are good hacks and bad hacks.
Yeah.
Where I wanted to jump to, I guess, communication and messaging versus RPC. I usually say prefer messaging.
Well, like,
for various reasons. I guess maybe we can talk on the coupling aspects of both. And maybe my question is, what examples have you seen where you can't get around having to directly, in a request response RPC fashion, communicate with another service? Because this is a question I get the most.
So I think when you really dig into it, I think the number of times where you can't, where you absolutely have to do RPC is relatively low. I think I think this is one of the problems that we fall into as engineers, as programmers, is that we think we want to make everything consistent, right? So we don't want to say, in a very simple example, yes, your order's taken, right? Yes, your order is taken, unless we've confirmed that it's in the warehouse and we can dispatch it. So because we want to be consistent, right? The system shouldn't take an order and say, yes, we're confirmed, if we don't have the thing. But then you talk to your business people and you say, well, you know, the problem is we can do it that way, but come Black Friday, our performance is just going to hit the floor. You know, we're not going to be able to handle too many simultaneous requests. You know, otherwise we're going to bring our web service down. They say, well, we need to just take as many orders as we can. And you know what? If there's a couple of things we can't supply, if we say, yes, we've accepted your order and then we haven't got it, it's okay, we'll order more, or in the worst case possible, we'll just send them a voucher for a refund. Or, you know, it's just an email saying, sorry, you know, would you like something else? So it's better just to say, yes, we've accepted your order, you're going to get this thing in 2 days, and tell a kind of lie, and then sort out any problems later, because you know that in most cases you're going to be able to fulfill that order. So take the order, write it down, right, which is equivalent of sending a message in a message queue, so basically writing it to disk, and just send back a 200 to the user and say, yeah, everything's fine. So it looks like RPC, but it's not, right? And in the rare cases it doesn't work out, you just take some compensating actions. And now that's a kind of very simple example, but I think when you drill into a lot of business problems where you have this need for consistency, which kind of drives this RPC thinking, it doesn't really exist once you get into the details of the business and what the possibilities are.
Yeah, I was going to say, I'm thinking of instances where you might have multiple business capabilities or services or whatever you want to call them. But then you might have the need to report and aggregate data from multiple of these quote services. I don't want to say obvious, but it seems like the obvious solution that developers probably have is, yeah, let's just put an API in front of all of those and just call all the APIs and combine that data into, I don't know, a view or a report or whatever. But I know there are different approaches. Do you have any comments on that, Adam?
Yeah, so if we're talking about, so what I was talking about previously was more with respect to taking an action. So, placing an order or updating some data or something like that. But if you're talking about queries, then that's slightly different. So as you say, you might have a page, let's say a product page on Amazon, which is made up from data from many different services. It might have something to do with the pricing, something to do with the product images, something to do with the ratings, and all the rest of it. So ultimately, yes, you do need to query those different services. But one of the interesting things about that is those different services can have highly different cache tolerance, right? So, for instance, the picture of the product, you might say, well, you can cache that for, I don't know, a week, right? We don't change it more than once a month. But something which needs to be more up to date, you might say, well, that has a cache maximum cache age of maybe an hour or something. It needs to be relatively up to date. So by making that separation, you can take advantage of that, and it means you don't have to query absolutely everything all the time, because a whole bunch of that stuff is just going to come from caches. So yes, effectively you've got many RPC calls to make up that page, but it doesn't necessarily mean you then having to go out and make 10 or 12 or 15 various service calls just to make up the page. There are also, if you've got lists of things, there are other methods of doing that where you don't have to then call, if you've got 10 items and for each item you've got 4 services, you don't have to make 40 service calls. You can actually just make 4 calls by passing around IDs and things like that. But that's probably a bit difficult to go into without showing an example. But I think that's something which some of my colleagues actually talk about in some of their talks. So there's a bunch of links I could provide you and the viewers with if they'd be useful.
Yeah, some of those get pretty involved. I know there's a concept of like rules engines too, where you have different services needing to interact with each other and kind of do different kinds of validation. So it's basically like a pipe, I guess, right? So you have like a pipe. Everybody needs to participate in this process. So you just kind of service A, you give him the data and he returns something to you, and then you get to pass that to another service and then pipe it down the line. So a scenario like that, which brings up the issue around like using microservices versus something more along the lines of like, what if you're doing like a modular monolith? Because then you get the benefit of having your different quote services, but they're all in memory, or at least pieces of them, I guess. Because this goes back to this whole idea of separating the logical versus the physical. Different services can deploy, let's say, NuGet packages and have one main process that collects all those packages and then orchestrates kind of this whatever process or flow that everybody needs to participate in. Mm-hmm. Yeah, that start getting a little more involved, I think, but when you compare that with like having all these quote microservices and having like RPC calls and REST calls between them, it does, I don't want to say it seems lazy, but and then a lot of times it's just people don't know better, right? But it does sound like that's easy to do compared to, let's say, the other approach.
Well, I think one of the key things to watch out for in that case is that you don't want this kind of all-seeing, all-knowing kind of God class or controller or MVC controller or whatever it is that kind of knows about all the services. So you don't want this one kind of kind of logical bottleneck, which says, well, I know I need to go and get the price from there, and I need to get the product ratings from there, and I need to get the product details from there, because then that becomes a kind of change and logic bottleneck in itself. So what you want in that kind of system is some very basic infrastructure. It doesn't really know anything about businesses, so it doesn't know anything about business capabilities. All it says is, let's say, well, here's kind of a view object, and you're going to put the stuff that you know about into it. You're going to put stuff that you know about into it. I don't care how you do it. And then some kind of branding service comes along and just puts some CSS on top of it and just makes it look nice. Because ultimately something's got to come together at some stage, and you want it to look consistent, right? So then you have this concept of a branding service. Now, a branding service, again, because it's not a physical thing, it's not a thing that you deploy, it's a logical thing. They might be a team of people who just supply style sheets or HTML templates or something like that. That's what that service ships as its components. But it's just another business capability, that service, this thing about presenting a consistent brand for your service. It's just another logical service.
Yeah, it's like you said, like at some point you have to glue things together, but I think the opposite, you think of like you're gluing things together as close to the user as you can, as opposed to let's glue everything in the database, for example. And it seems like
that's the thing. You don't want zero coupling, right? Yeah. Because like the name of the show, you want loose coupling, right? So loose coupling is a good thing. Tight coupling tends to lead to problems. Zero coupling is useless because then your system can't really do anything.
Yeah.
So it's just the tuning and finding that couple point. That's the key to this.
So the last thing I really have, and then I'll let you segue, James, if you got anything else, was we talked a little bit now, we've mentioned it a few times, versus logical and physical. Do you think 4+1 is if that's new to all people, like what we're talking about, physical, logical, and why they're different? Because I always think that has been lost with microservices, where they seem to be have turned into one. Do you think people, if they're unfamiliar with 4+1, that's the place to start? And maybe touch on that a little bit.
I think it is very similar to 4+1. Yeah, it is that kind of, that there are these different viewpoints which look completely different to each other, right? And that is the key. Yeah. So it's related to 4+1. It's not exactly the same type of thing, but the important aspect is that the logical does not equal the physical, and the logical view is very different, right? It is very, very different to the physical one, and it is ultimately what drives the physical, right? So you start from the logical, and then your physical falls out from that in terms of what it makes sense to deploy, right? If that makes sense. So yeah, there are similarities to that. So I think it's good reading to realize that you can look at the same system in many different and in different ways, and actually very, very disconnected ways. Just to give you a completely different view of the system.
Yeah, it makes sense to me.
Yeah.
Cool. Well, I think we're gonna end this. Thanks, Adam. Thanks for your time, and it was a good chat. I know I have more questions, but you'd be here.
No worries. Well, thanks for having me on the show. Yeah.
Yeah, it's cool. I think we reached a bunch of stuff that I was interested in. It's an interesting topic. It's so nuanced too, because trying to get people, and I'm assuming you get a lot of these questions kind of after talks and stuff, it's really hard to give people a formula for boundaries or cues or things that they can actionably take. I find it really difficult. I don't know. I find it really difficult to people want like a concrete plan of this is what you go do, and it's very, it doesn't seem prescriptive.
I agree with that. I agree with that. There is no formula. That interestingly, the technical side of things, so how you deploy things and create deployable components and those kind of things, they're more formulaic, right? So those are things that you can more kind of say, well, this is how you do that. But as for finding service boundaries, there simply is no way to do that, because every place you look is different to every other place you've looked when you're looking in a business domain. And I think we like to spend our time in code as engineers, and try and solve things from that point of view. But if we often ask those more difficult questions at the logical level, the code that falls out at the end is very simple. It's actually just really simple code. And you find yourself not having to deal with gnarly race conditions and things like that, because the business, those things don't really exist in a business. Once you find out the business rules, then those things kind of fall away. So there will always be tough questions in business, and that's not going to change. Whereas you can make the tough questions in the technical side, you can kind of make them fall away.
Yeah. Cool. Well, thanks again for doing this. This was, I think, pretty insightful.
Yeah, it was fun. It's definitely a topic of interest, big interest for me. So
cool.
Right,
Thanks.
Thank you too.
We hope you enjoyed this episode of the Loosely Coupled Show. If you did, please subscribe for more on software architecture and design.